This is episode 9 of the podcast, The Tech Lounge, discussing private AI versus public AI. Where should enterprises draw the line? And welcome, everybody. Pull up a stool, grab a drink, get comfortable. We are so glad you could join us.
Yeah, definitely. It's good to just, relax and talk through this stuff.
Exactly. So today, our mission for this deep dive is going through a honestly massive stack of tech architecture briefings and enterprise strategy guides from right now in 2026.
And it's a heady stack.
It really is. But it's fascinating because the stakes of this entire conversation have fundamentally changed. I mean, the era of writing passable poems or, having a chatbot summarize a news article back in 2023, that is ancient history.
Oh, totally. A completely different world.
Right. Today, we are talking about AI systems making autonomous decisions. They're executing million-dollar financial trades and reading highly classified non-disclosure agreements. So the choice between public and private AI isn't just a fun tech debate anymore.
No, not at all.
It's basically a make-or-break business survival decision.
Yeah, the landscape has completely matured. I mean, looking through this stack of research, every chief technology officer is essentially facing an existential crisis right now.
100%.
Because the conversation is no longer about whether a company should deploy AI to stay competitive. That ship sailed a long time ago.
Yeah, you're dead in the water if you aren't.
Exactly. The question keeping them up at night is how to deploy it securely and at an immense scale without spiraling into bankruptcy or violating all these sweeping new international data laws.
Okay, let's unpack this a bit, because to really understand this tug of war between public and private infrastructure, we have to look at why it's happening right now.
Yeah.
Like the mechanism of how AI operates in the corporate world today.
Right, the shift in integration.
Yeah, exactly. We've moved from those sporadic, isolated web interfaces to deep, invisible operational integration. The industry is calling this Agentic AI.
Which is a huge buzzword right now, but it's real.
It is real, and we need to be clear about the sheer scale of that term. We aren't talking about a helpful little digital assistant waiting for you to type a question.
No, not at all.
We're talking about autonomous software agents wired directly into corporate databases. They can reason through multi-step problems, plan out a sequence of actions, and just execute them without any human intervention.
And that operational integration changes the fundamental risk profile of the technology. I mean, think about it.
Oh, it has to.
Right. When an agent is tasked with reading a proprietary database, cross-referencing it with complex compliance rules, drafting a bespoke client contract, and then autonomously emailing it out.
That's a lot of power.
It is. The data involved in that process is the lifeblood of the company. It's their core intellectual property.
Which, brings me to a major question. And I think is one a lot of people listening are probably asking. Let's say I'm running a massive logistics firm, right? Or a bank.
Sure.
If my agentic systems need to do incredibly complex, multi-step reasoning, why wouldn't I just rent the biggest brain available?
Ah, the classic public utility argument.
Right, because the giant tech vendors building these public AI models, they are spending billions of dollars a month on compute. They have data centers the size of small cities.
I do.
So shouldn't I just plug my company into that massive public API to beat my competitors? I mean, why would I try to build my own inferior version?
That is the default assumption for a lot of business leaders, but the technical reality of 2026 points in a totally different direction.
Really?
Yeah. One of the most fascinating metrics we pulled from the architecture guides shows that by late 2025, the performance gap between the absolute bleeding-edge proprietary public models and the top open source models basically vanished.
Wait, vanished? How close did it get?
It shrank to a razor-thin 0.7% on complex reasoning benchmarks.
Less than 1%?
Yep.
So you're saying the gap between a billion-dollar corporate black box and a model you can just download and run yourself is essentially a rounding error.
It has completely evaporated. Intelligence is commoditized now. And we should probably clarify what an open weights model actually means functionally for the listener.
Yeah, that's a good idea.
It basically means the architectural blueprint of the AI, all those billions of pre-trained neural connections or weights that dictate how it understands language and logic that is available for anyone to download.
And just deploy on their own hardware.
Exactly. You might not have the massive pile of original training data the big guys used, but you have the fully educated brain.
Wow. So pure intelligence has essentially been commoditized.
Absolutely.
If I have access to a genius-level open weights model, and my competitor does too, then simply plugging into a smart API is no longer a competitive advantage.
No, your capabilities are totally homogenized at that point. The competitive moat has shifted entirely.
Okay, so where is the moat now?
The real advantage today is having total, uncompromising control over the infrastructure. It's the ability to customize a highly capable AI using your own unique, highly sensitive corporate data.
Okay, that makes sense. So since customization and control are the new gold standard, let's clearly define the two distinct paths businesses are walking down today to achieve that.
Right, the public versus private debate.
Exactly. We are looking at the public AI utility model and the private AI sovereign model.
Let's start with public AI. It's essentially AI as a service. You are renting a brain by the millisecond.
Like a utility bill.
Exactly. You do not own the model, you do not own the infrastructure, and you have zero control over the billions of parameters that define how the model behaves.
You're just sending requests.
Right. You are simply a client sending a data payload across the open internet to a vendor's API. And structurally, it is built on multi-tenancy.
Which means shared hardware.
Yeah. Your data is being processed on massive clusters of GPUs that are simultaneously processing requests from thousands of other companies.
Okay, I want to introduce an analogy here to explain the real vulnerability of that multi-tenant setup because it's so important for you listening to grasp this.
Go for it.
Think of public AI like a sprawling, beautiful neighborhood park.
Okay, a park.
Right. It is highly convenient, anyone can walk in, and the city maintains the soil. You don't have to do any of the hard work.
Sounds great so far.
Right. But if you have these incredibly rare, prized, proprietary tomato seeds, which represent your highly sensitive corporate data,
Okay.
and you go plant them in the public park, you run a massive risk. It isn't just that someone might steal your tomatoes.
Which they might.
Right. But the real danger is that the soil itself, the AI model, absorbs the nutrients and characteristics of your specific seeds.
Oh, wow.
And next season, the park uses that enriched, fine-tuned soil to grow equally amazing tomatoes for your biggest competitor. Your proprietary advantage just leaked right into the public commons.
That is a brilliant way to look at it. It captures the data leakage mechanism perfectly.
Thanks.
Yeah.
Because the vendors might promise, zero retention policies, claiming they won't use your prompts to train future models.
But that is merely a trust-based legal guarantee. It is not a technologically enforced boundary. You cannot inspect their model weights or audit the exact processing logic. Like we said, it is a black box.
So what's the alternative? Private AI is the sovereign model. You host the AI on physical servers inside your own data center, or maybe within a virtual private cloud.
Or a sovereign cloud tied strictly to your country's borders and laws, which is getting huge.
Yeah, we're seeing a lot of that in Europe.
Yeah.
But the golden unbreakable rule here is that the data never leaves your perimeter during inference.
And let's just define inference briefly, because it is the crucial moment in this process.
Good point.
Inference is the actual act of the AI processing your prompt and generating a response. This is distinct from the initial training phase where it learns the language.
Right. Inference is the actual thinking in real time.
Exactly. In a private AI setup, inference happens behind your walls. It becomes a glass box.
So your engineers can look right under the hood.
Yeah, they inspect the parameters and, crucially, they lock in specific versions of the model, so a random update from a vendor doesn't suddenly break your company's entire automated workflow overnight.
Going back to the analogy, private AI is your own walled personal garden. You have to buy the expensive land, you build the heavy stone walls, and you maintain the soil yourself.
A lot more work up front.
It is. But you keep absolutely everything you grow, the soil never leaves your yard, and you alone hold the key to the gate.
And what's fascinating here is that holding that key enables a concept the industry calls super agency.
Super agency, I love that term.
It's great, and it's impossible in the public model because you cannot safely give a public AI model the API keys to your internal financial databases or your customer relationship management system.
No, that would be insane.
The security risk of handing external multi-tenant infrastructure the keys to your internal kingdom is catastrophic.
It's like handing a complete stranger the master keys to your house and just hoping they only water the plants and don't look in your filing cabinets.
Exactly. But a private AI agent sits safely behind your corporate firewall. The brain is sitting in the same secure room as the hands.
Right.
So you can grant that local agent deep, unrestricted access to your databases, empowering your employees to automate incredibly sensitive workflows.
And without a single byte of data ever crossing the public internet.
Precisely.
So, okay, we have established that private AI gives us this perfectly secure, customizable walled garden with super agency. The obvious follow-up question any business leader reading these guides would ask is, why isn't every single company just building one tomorrow?
Right.
Like, why does the public utility model even still exist for enterprise use if private is so much better?
Because the barrier to entry is the sheer physical heavy lifting and the infrastructure economics. Running these systems requires an immense amount of capital upfront.
Let's talk about those economics.
Yeah.
Because the math we are seeing for 2026 holds a massive surprise.
It really does.
But first, we have to look at the sneaky, variable financial danger of using public AI, which our sources call the token trap.
The token trap is just wreaking havoc on corporate budgets right now.
How so?
Well, public models charge per token, and a token is roughly, 3/4 of a word.
Okay.
They charge for the tokens you send them as a prompt, but they charge significantly more for the output tokens they generate in response. Output tokens can cost 3 to 10 times as much as input tokens.
And when you add in context caching, where the AI has to keep long, ongoing conversations or massive documents in its active memory just to maintain context, those token counts explode.
They compound so fast.
Yeah, if an agent is autonomously drafting 50-page compliance reports or generating thousands of lines of code, the output tokens just spiral out of control. We read a terrifying anecdote in the briefings.
Oh, the billing one.
Yes. Companies were modeling their costs on early experiments, projecting a neat 50-pound monthly bill.
Nice and manageable.
Exactly. Then, as they integrated agentic workflows, they suddenly received a 50,000-pound invoice.
It creates a completely unpredictable variable cost structure that scales aggressively as your company becomes more productive.
Now, let me push back here on behalf of the CFOs listening. Because if my company is looking at a surprise 50,000-pound bill, I'm immediately picking up the phone.
Naturally.
I'm calling my public vendor and negotiating a flat rate bulk enterprise tier. I have purchasing power. Why on earth would I go through the headache of sourcing hardware and building my own server farm when I can just negotiate a better API rate?
Because even the most heavily discounted enterprise tiers from public vendors are ultimately usage-based. They have to be.
Why is that?
The multi-tenant vendor is paying for the electricity and the hardware wear and tear for every single token you generate. They cannot offer a truly unlimited fixed cost buffet without taking a massive loss on heavy users.
That makes sense.
Plus, as we discussed, even an enterprise tier doesn't solve the super agency problem. You still can't give them your internal database keys. To get flat, predictable costs and true security, you have to look at the physical hardware of private AI.
Okay, let's break down that hardware reality then. What does it actually cost, and what does it take to run a highly capable open weights model locally at the speed an enterprise actually needs?
You need serious silicon. In 2026, the gold standard for enterprise inference is still the NVIDIA H100 GPU, or, its immediate successors.
The big guns.
The really big guns. A single H100 chip draws roughly 700 watts of power under load.
Wow.
Yeah. You cannot just plug that into a standard server rack in your IT closet. It requires specialized cooling infrastructure, reinforced power delivery, massive data center planning.
So it's a huge logistical headache.
It is, and because global demand is so intense, sourcing these chips for an on-premise build can involve a 5 to 6 month lead time.
6 months just to get the hardware.
Easily. And if you bypass buying them and just rent a dedicated cluster of H100s in a private cloud environment, you are looking at 12,000 to 16,000 pounds a month in fixed infrastructure costs.
16,000 pounds a month sounds like an incredibly steep barrier to entry compared to a pay-as-you-go API.
It does.
But the financial modeling in our sources reveals a clear break-even point, doesn't it?
It does, and it's lower than you'd think. Once a company's agentic workflows pass roughly 1 million tokens a day in processing, the math violently flips.
Really?
Yeah. Private AI goes from being an expensive luxury to being significantly cheaper than paying public API fees.
It transforms your AI budget from a variable risk into a step function cost.
Exactly. Once you lease or buy the hardware, it doesn't matter if you run the GPUs at 10% capacity or 99% capacity. Your monthly spend is flat and predictable.
Beyond the raw financial math, there is another hidden operational cost to the public utility model that we need to talk about.
Latency.
Latency. Speed.
Yeah, the speed of the response is absolutely critical for these multi-step agentic workflows. When your system sends a request to a public API, the latency is entirely at the mercy of network traffic and vendor server load.
Right.
So one request might take 400 milliseconds, but a minute later, during a peak traffic spike, an identical request might take 3 full seconds.
Now, 3 seconds doesn't sound catastrophic if a human is waiting for a chatbot to draft a marketing email.
You just sip your coffee.
Exactly. But when we talk about autonomous agents, that delay is paralyzing. If an agent has a complex 50-step reasoning chain to complete a single task, and it has to query the public model 50 times,
That's a lot of waiting.
an unpredictable 3-second delay compounds into minutes of dead time. It just fractures the efficiency of the entire automated workflow.
But by running private AI on dedicated, locally optimized hardware, companies are hitting deterministic sub-200 millisecond response times consistently.
Sub 200 milliseconds, that's virtually instant.
The agent can think and act almost instantly because it isn't waiting in a queue at the public park.
Now let's pivot a bit, because even if a CFO is perfectly willing to eat those massive public token costs, and operations is totally fine with the latency, their legal department is going to shut the public API down anyway.
Oh, without doubt.
Because for certain industries, this isn't about budget at all, it's about staying out of court.
The regulatory environment in 2026 is completely uncompromising. As of August this year, the European Union's AI Act is fully operational and enforcing very strict penalties.
And it categorizes AI systems by risk.
Right. If a company is running what the EU legally defines as a high-risk system, which covers AI used in employment recruiting, critical infrastructure management, or determining access to essential private services like loans, the legal burden is immense.
What do you have to do?
You are mandated by law to provide comprehensive documentation, traceability of decisions, and proof of human oversight.
Traceability. But how do you prove the traceability of a decision when the engine making that decision is a black box?
You simply cannot.
Right.
You do not know what specific training data the public vendor used, you cannot inspect the inner logic, and you cannot guarantee the consistency of the model version.
So if a public AI denies a user a loan, and the regulators audit you.
A conformity assessment under the EU AI Act will tear your architecture apart.
Right.
Because you are legally responsible for outputs you cannot mechanically explain.
The regulatory friction gets even more complex when we look at the intersection of AI and GDPR. Specifically, the GDPR right to be forgotten.
Oh, this is a massive issue.
It's one of the most brilliant, highly specific dilemmas we explored in the deep dive. Let's say you send a batch of data to a public model, or use context caching, and the neural network accidentally absorbs and memorizes a specific customer's personal data into its weights.
Which happens all the time.
And the next day, that customer exercises their legal right to be forgotten and demands you delete all trace of them.
Making a standard large language model unlearn a specific piece of information is technically non-trivial.
Understatement of the year.
Honestly, it is nearly impossible without retraining the entire model from scratch, which costs millions of dollars, because the data isn't sitting in a neat little file folder inside the AI.
Right, it's not a spreadsheet.
It is baked into the neural network's billions of connections. Think of it like baking a cake. You mix flour, sugar, and eggs and put it in the oven.
Okay.
Once the cake is baked, you cannot ask the chef to extract just the flour.
No, of course not.
The ingredients have fundamentally transformed into a single entity.
So to solve this impossible baking problem, private AI utilizes a specific architecture called RG. That's Retrieval Augmented Generation.
And RG fundamentally changes the mechanics of how the AI interacts with your data.
In a private RE setup, the intelligence of the AI model is kept entirely separate from your corporate knowledge base. The AI does not memorize your data during training.
Right, the data is stored in a specialized system called a vector database.
Let's explain how a vector database works, because I find this so cool. Think of a vector database not as a traditional filing cabinet organized alphabetically, but as a vast multi-dimensional map.
A mathematical map.
Yes, it plots concepts and data points by their mathematical relationship and meaning. When you ask the AI a question, it doesn't search its own memory. It sends a search query to this map, retrieves the relevant coordinates and data, and brings them back.
So RAG essentially gives the AI a temporary scratch pad. It retrieves the necessary facts from the vector database, writes them on the scratch pad, formulates a natural language answer for the user, and then wipes the scratch pad completely clean.
The underlying weights of the AI model are never permanently altered by the information.
Exactly, it's an open book test.
The AI doesn't need to memorize the textbook. It just looks up the answer when prompted. So if a user invokes their right to be forgotten, you do not have to retrain your multi-million-dollar AI model.
No, you simply go to your vector database, locate the mathematical coordinates of their specific data, and hit delete.
And the next time the AI searches for that person, the data is gone. Instant, mechanically verifiable GDPR compliance.
This separation of logic and memory fundamentally changes the risk profile for an enterprise.
It really does. Let's ground all this deep tech and legal theory in the real world, because we want to see how actual businesses are drawing the line today.
There's some great case studies in the briefing.
Yeah, the legal sector is a perfect example. I was totally geeking out over how a major law firm tackled their contract processing bottleneck.
What with the M&A documents?
Yes, they were drowning in massive, unstructured merger and acquisition documents. And they couldn't use a public API because of attorney-client privilege.
Uploading a confidential merger agreement to a multi-tenant cloud is an instant waiver of that privilege. The data breach risk is just way too high.
So they built a walled garden. They deployed a bespoke private AI agent utilizing our RAG on their own secure servers.
And the performance metrics on that private deployment were staggering.
Because the model was hyper-focused on legal language and isolated from generic internet noise, right?
Exactly. It processed complex contracts with 95% accuracy.
Yeah.
It actually beat the massive generalized frontier models.
That's incredible.
And it completed the work 92% faster than their human